Hey guys, so what we what we're going to do right now is we're going to use the Cartesian plane to define the trigonometric ratios. Ne? We already did define the trigonometric ratios, but now we are just using the Cartesian plane to do that. Ne? And this how it is done. Basically, they will say there's a circle. Hopefully, it becomes a perfect circle. Let's see. So you have a circle like this, but yeah, no. This one is not a perfect one. No, let me see. Yes, man. Alright, cool. So say you have a circle like that, and on your circle, of course, this is going to be, if we draw a line from the center of the circle to the circumference, that line becomes the radius, right? It becomes the radius. And then in us drawing that line, we form an angle, which is theta. So in the Cartesian plane, angles are measured anti-clockwise. This is how we measure angles. So yeah, and then what happens is with that angle being formed, we can construct this side, right, which forms a 90-degree angle right here, right? And then let's talk about the distance from P to the x-axis. What is changing? You move from here, you are on the straight line. You move from x-axis to P. The thing that is changing is y, right? So we can say that this is changing y, right? Yeah, or you can just say that is just y, because like you're moving from y being 0 to y being a positive number, so that number will just be y, right? So yeah, I'll stick with y for now. And then the same analogy is true for x value. So we move from 0 to this value, this side, this length. This is going to be x. Yeah, well, so now we can cook. We have our radius that side, right? Cool. Now we can cook. All right, so if we cook now, what is sine? Sine is opposite. What is opposite theta? Opposite theta, we have y, right? Hypotenuse is r. Cos theta, what is cos theta? Adjacent to theta, we have x over our hypotenuse, which is r. Opposite, we did say it's y. Adjacent, we did say it's x. So with this, guys, now with this, you have defined trigonometric ratios using the Cartesian plane, right? And even if like we have angles on the other side, the same will be true. All right, so let's do this. Let's take this man down here with us. Beautiful thing, So here on this diagram, we can use the same analogy, whatever. We have this side, but we can tell already that this side is y, therefore this side is 3, this side is x, therefore this side is 2, right? And also like we have, so like I said, we measure angles. So you see angle B, we measure it from here to here. We measure angles anti-clockwise, right? Yeah, we measure angle anti-clockwise. So now there's a concept that I want to bring to us. I was gonna do it in the next video, but I might as well just do it here. It's called the cast rule, cast rule. Sorry for that. So this is your y-axis, x-axis, Cartesian plane, Cast rule, it goes like this. It's C-A-S-T, right? Cast. Right. So this cast, what it means, it tells you which trigonometric ratio is positive where, right? So here, all of them, this is A for all of them are positive in the first quadrant. Second quadrant, only sine is positive. Now, Third quadrant, only tangent is positive, the rest are negative. And then fourth quadrant, only only cos is positive, then the rest are negative. Yeah, well, so let's get down to it. Just want to show you guys with this one. You see here we're on the second quadrant. We are expecting only to have what? To have sine being the positive one. And so when you go, we know that sine is y over r, né? And then we don't know r, so we'll just use r this time. So yeah, therefore here sine is going to be what? Y, which is 3 over r. R is always positive. I will show you guys why I mean that. But yeah, r is just a distance, it's just a radius from the center of the circle to the circumference. And then cos is x, which is minus 2 over r. Tangent is 3 over minus 2. Right, so you see this one is negative, this one is negative, and this one is the only one that is positive, agreeing with what we said. Né? If we can bring the same line here as well and say, look, here we have minus 2, we have minus 2, minus 3, right? If we do it like that, you would see you have tangent is going to be, say that forms an angle called alpha. Tan alpha will be minus 3 over minus 2, which is 3 over 2, which is positive. Nah. Then the rest, when you talk about sine is y, so minus 3 over r, which is negative, and then cos alpha minus 2 over r, which is negative. Yeah, well, so this is it in short. This is it in short. So the cos rule, it tells you where your angles are, which trigonometric ratios are negative and where are they negative, and so forth and so forth. But the structure that you guys need to know is this one, right? And how do you start with that? You start with this, and here you don't need to like even draw the circle. You just need to form your triangle and say, okay, this is y, this is x, and then there is theta. Then you define your trigonometric ratios. From then, after you've done defining your trigonometric ratios, you can solve any problem that you have. Let's see. We have p, right? We have p, which is minus 3 and 4, right? And then we have to find cos theta, right? And here, look, you can draw the triangle, the Cartesian plane. It is going to help you. Né? But say, for example, you already know them by heart. You know sine is y over r. Oh, something I didn't talk about. Let me go back. So I did say this is the radius, né? And the radius, like, or how it calculated, we're going to use Pythagoras theorem based on the triangle we have formed, right? And the Pythagoras theorem will say x squared plus y squared equals to r squared. And this is how you'd find your r, né? Cool. So let's come here. So then they say we have x and we have y. They say find these things, né? 1, 2, 3. Say you have memorized your trigonometric ratios defined using Cartesian plane. You have memorized them, so you don't have to stress about them. So we continue, né? You like, okay, let me say x squared plus y squared. It's gonna give me r squared. X squared, that's minus 3 squared, plus y squared, 4 squared equals to 5. Then you have 9. You have 9 plus 16 equals to r squared. You have 25 equals to r squared, and therefore r equals to 5. So you have 5. You calculated that r. And it's very important also to show this on your workings. And then here you say cos is x over r, which is minus 3 over 5. Yeah, 3 tan theta, it's gonna be 3, and then tangent is what? Y over x. Y over x, and that is going to be 3 into y is 4, x is minus 3, so you're gonna have minus 4, minus 1, minus 4, minus 4, minus 4. Right. You go now. Cool. So this is now it brings another idea, right? We have this thing called reciprocal ratios, right? Which is, so you have sine theta, cos theta, tan theta, right? And then you will have your cosec theta, you'd have your sec theta, and I think this is cot. Yeah, this is cot theta, right? So by defining these, you know, this is y over r, this is x over r, this is y over x. These are the inverse of these, right? So them being the inverse, it therefore means here we have r over y, we have r over x, we have x over y, right? These are the reciprocal of these, and it's like having 2 versus 1 over 2, right? So cool. So this one of cosec, you know, it's r over y, which is 5 over 4. Oh, I forgot the half. 1 over 2, 1 over 2, which is 5 over 8. And yeah, so but if you happen to have forgotten how it's done, you just draw your Cartesian plane quick, right? But sometimes it becomes really tricky. So you don't have to draw this one exactly, right? But you just draw something that is going to help you. No. So you'll say perhaps you have theta here, and then you have your point x and y, right? Then you know this is y, this is x, and then you define your trigonometric ratios. Then you come here, right? Because of course you see this point now, it's going to be where x is negative, and 4 is 4 is positive, so it's somewhere here, right? Oh no, yeah, it's gonna be somewhere here, right? You have x being negative 3, and you have 4 xy being 4. Let's see. You have p here, and they gave you r. We have to find r. So here you don't have to stress. You know that x squared plus y squared equals to r squared. So you know x, which is minus 5. So minus 5 squared plus y squared, 13 squared. 169. 13 squared. All right. Minus 25. This is squared, y squared, that is 144, which therefore y is equals to 12. Yeah, bro. Let's see what we do next. So here we are proving that tan squared theta plus sec theta equals to cos. Cool. But the question is, why did I put this one here? Because we are doing the things. Let me think. Why did I put this one here? All right. Okay. Okay. That is fine. Because now, I'm thinking of identities. Oh, I understand why we put it here. I understand. Yeah, it's a perfect example. So you have tan, right? Tan, tan theta, you know it to be y over x squared. plus 1, right? And then I have y squared over x squared. I have plus, say, x squared over x squared, right? And then I continue, y squared plus x squared equals over x squared. Yeah. And then I continue this over here, it gives me r squared. Then I have x squared, right? So I will end it here. But now remember, cos theta equals to x over r, and therefore sec theta will be r over x. And if we square it, then we'll have squared and squared, right? Proving that the left hand side equals to the right hand side. Yeah. Okay, cool. All right. So here, man, I have things I don't understand. What was I doing here? Let me see, bro, because I don't understand this question. Actually, I didn't write it in full. Yeah. So we're going to use this information, of course, to find this guy, right? But I'm sure I have something missing. Let me confirm. Yeah, guys. So I just investigated, and with my suspicions, I was right. What I had doesn't make sense. So here I have cos beta. Yeah. Oh, yeah. Because what I had there didn't even make sense to me, bro. So this then let me see. Yeah. So that 10 cos beta say equals to minus 8, and then what is that? Then cos beta gives us minus 8 over 10, but I know that cos is x over r, right? So I can use this 2 to find y. X squared plus y squared. Therefore, I'm going to have r squared, which is 10 squared, minus 8 squared, y squared, 100, minus 64, 36, y squared, and therefore y equals to 6. It's crazy here. I have cos. Let me just make it a sine. So here then sine, I know sine is y over r, which is 6 over 10. Yeah, for this one you have 3 over tan. Let me write it this way. You have 3 divided by tangent. Tangent is y over x, so therefore I have 6 over minus 8, plus 2 multiplied by sine. I have y, which is 6 over r, which is 10, but I have it squared. So then I have 3 multiplied by minus 8 over 6, plus 2 multiplied by 36 over 100. Here then this is just pure mathematics. This 3 will be divided by itself, and then here would have 2, and then that 2 divides here, we have minus 4, plus I'll have 72 over 100, right? Yeah, I could turn this into 400, so minus 400 over 4. Oh, that's gonna give me now I want to have 100. Yes. Oh yes, this is fine. Yeah, so then therefore the final answer is going to be negative 328 over 100. Yeah, let me see. 328 over 100, which is 3.28, but of course it's negative. So if I have 72 over 100 minus 4 minus yes. So these are using trigonometric ratios into the Cartesian plane. Let's call it a day. I'll see you in the next video.